Colloids are everywhere. Okay, they're everywhere in our everyday life. Okay, you may not realize it, but you can see it in paints, you can see it in pastes, you can see it in high-tech ceramics, you can see it in photonic materials. And even sort of the ideas about color and things like that, how to control it, part of those ideas can emerge from colloid science. There's lots of things that, of course, we can gain by understanding these materials at a fundamental level. To control them, we want to understand them, and the microgravity environment lets us understand them in lots of new ways. And then what we're doing in the experiment, we're going to do several things. One of the cornerstones of it is to study how a crystal can turn into a glass. So you're probably used to making a glass. Basically what they do is they start it with a molten material and they cool it very rapidly. And then the atoms get frozen into place. It becomes, if you like, a solid. Glasses are as you know, they're fragile. Okay, so it may be hard, but it's fragile. It's better if I had a hard material that was tough, okay, that didn't just shatter. But you can also have a crystal becoming a glass. And you could do that by, for example, adding disorder into the crystal. Okay, so for example, if I have a crystal of particles and I just mix in a small number, say a few percent, of a particle of a slightly different size, the more and more you add, the more and more potential for disorder. And what we found in some experiments in 2D on Earth, if you have even, relatively little amount of dopants, you can actually have the crystal suddenly be converting into a glass. Most of the work done about glasses has to do with looking at going from a liquid to a glass, or instead of a liquid to a crystal. What we're doing then is we're going to go all the way. We're going to go from having liquids to glasses to crystals. Go one way, go the other way, and look at how does the transformations occur. We're going to be able to look at those rearrangements because it's very interesting. The structure is almost exactly the same, but the dynamics get slower and slower. So we want to understand the mechanical properties of these disordered systems, and that's hard because it's hard to identify what the defects are. That's one important problem. There are other interesting problems about glasses. Now, we're going to study glasses. Okay, in these experiments that we're going to look at, we're going to basically make supercooled liquids, make glasses, and then look at how the dynamics varies in these systems, okay, and how it's related, if you like, to structure. This is a new kind of problem, which actually it turns out is interesting again from a commercial point of view, because, for example, in pharmaceutical industry, often you want to have a material that sort of dissolves quickly or slowly into the body. It turns out that if you have a crystal of this stuff, that it actually might dissolve very slowly. But if you have a glass, it might dissolve quickly, so that could be good. It's interesting to think about how we can make something, maybe it's easier to make it initially as a crystal, but how we can make it become glassy. The opportunity, again, to use a confocal microscope in space is absolutely crucial to looking at the sample in 3D. And so that lets us look inside the sample rather than just on the surface of it. And so we can really look at the internal dynamics. That's giving us fundamental information about the nature of a glass. Okay? And we're really able to do it because we can look at all the atoms, we can look at all their positions, and we can do this over a long period of time and in a thermodynamic system because it's in microgravity. The scientists and the engineers at NASA, and working with them at NASA Glenn, they're the sort of the blood that makes the system work. They understand what we need to do, they understand the hard things that I don't understand, right? I'm always sort of thinking you can do this, and they're making it happen, okay? But then I find out as they're doing it that it's not so easy to make it happen. It's a great group to work with. They're super committed to not just my project, to lots of different projects. And the idea that you can do really fundamentally new things in space that you can't do here just on Earth. In terms of what I would like, I mean, the sky's the limit, really. What are the possibilities for assembly with colloids in a broad sense in microgravity? Because we can maybe do colloidal engineering ultimately to make novel materials that are useful for applications on Earth but are hard to make. It's an interesting potential use for microgravity.